Oh shoot, I forgot my homework.
Oh, Landon. I will never forget to put zeros in the grade book. Who's absent? You're not absent, Genevieve. You're here.
I was absent yesterday.
So I will give you a worksheet in class.
The last 4 were so odd. I put already so many worksheets.
Because remember, this is just one section, and I didn't like the way they did it, so I broke it up into one. Jenna, close the door for me. Oh, thank you. Put +1 up there on the
Like,
board.
I found like a bag and like what class is it?
Put
It's Ace.
put +1.
No,
Minus.
I got +1.
My desk.
Here we go. Questions on the homework. Questions on the homework. Jackson said he doesn't want to do the fraction ones.
I didn't want
Abby. Number 9. All right, says the following. Actually, today number 9 is today's homework, so we'll look at that today.
Right. Did I do it right though?
You started off correctly. Yep.
I did right.
Yeah.
You already taught 5 and 6.
I did. Go ahead. Number 5 and 6 are your fraction ones, so I will do one of them. The other one's done the same way. So number 5 starts off, you got a mixture of fractions and mixed numbers. I'm going to always recommend change your mixed numbers to improper fractions. So if we change the first one to a improper fraction, we get -5/3, and the variable is n. And we're told that subtract that from -7/2. I wrote that as a improper fraction. Didn't I just do this literally yesterday in class?
Yeah.
Yes. Okay. And that equals -7/2. Okay. I'm going to get rid of the -7/2 first. So how do you get rid of -7/2? I add 7/2 to both sides. So I add 7/2 to both sides. 7/2 minus 7/2 is 0. So we get -5/3 n is equal to literally 0. So if you want to think of this through, well, then it doesn't matter what I multiply both sides by, it's going to end up being 0. Right? The only thing times a number that is 0 is if that other number is 0. So n must be 0. Now, if you want to completely do it the correct method, right, we need to multiply both sides by this one flipped. You get rid of something attached by multiplication, you divide. We're dividing by a fraction. So I take, when it's a fraction attached to a variable, I flip that one and I multiply both sides by -3/5, right? -3/5. Now, if that was not a 0 right there, this would result in something, right? In this case, anything times 0 is 0, so we get n is equal to 0. Okay, cancel. That's 5, correct. All right, any other questions? I'm not doing 6, but yes. 13. We're going to do rows like in class today. So yesterday was a preview. Today we're going to do a bunch of them in class. All right, so here we go. Number 1. You got to tell me if this is right or wrong. This is Jackson's answers.
Wrong.
All right. Well, how do you know?
Because he's always.
If he gets them all right,
He's
and
more right than
then
you.
he will have no homework, and you will have double homework.
That is a bet.
Okay.
No.
And if he doesn't get
I can't. He has a couple of them anyway. I can't do that. All right, here we go. Number 1, p is equal to -12.
correct.
All right. Number 2, a is equal to 8.
And
Number 3, m is equal to -32. Yes. No. -16.
yes.
All right. Well, I see you wrote the right
That's
thing,
tough.
but you tried to do instead of writing +1 on both sides. Right. It happens. Number 4, he's claiming x is equal to 19.
Yeah.
Yeah.
You're wrong. It's 19.
152 divided by 8 is
19.
19. All right, we said that 5n was equal to 0.
Yes, sir.
Number 6, I don't have the answer. Who's got it?
Negative 103 over 36.
That doesn't sound right. 5 was 0. Let's see.
Mixed number or non-mixed number?
Well, let me do it real quick and then we'll talk about it. I want to make sure I put up the right answer. Jackson said, I'm not having any of that. I'll just take the 0 on that one. All right, so let's see. We got 29 over 18. And that's supposed to equal 5/3 and minus what, 11/3? Is that right?
Yeah.
All right, so let's add 11/3, but we got to make common denominator 18. So that would be instead multiplied by 66 over. So add 66. I wrote 16. Add 66 over 18 to 29 over 18. 88 plus 9, 97 over 18. Is that right?
It's 66, not 68. Yeah, that's a 66. It's
That's mistake.
Where?
It's not there.
68 right there.
Got it.
66.
I
Who
already
called that
said that
first?
mistake.
Who called that first?
I did.
All right, so that would be what? 86 plus 9, 95.
95 over 18.
Okay, so we get 95 over 18 is equal to 5/3 n. And we're going to do a copy dot flip. So we're going to multiply both sides by 3/5. By 3/5. All right, anything cancel? Yep. 5 goes into 95. 19 times, and 3 goes into 18 6 times. So we get 19 over 6
Equals that.
equals n. Okay.
Well, I got that wrong.
have done that.
All right. Jackson's claim on number 7 that r equals 4.4.
I got so. Oh, yeah, I
I
did.
got 4.4.
4.4.
I got 4.4.
If we add 1.5 to both sides, we would get 2. And if we multiply 2.2 times 2, we get 4.4. All right. Number 8. He's claiming n is equal to -7.
I got
That's mistake.
5.5.
I got 5.8.
You subtracted 2.9 from both sides. We add 2.9 to 10. We get what? 13.2. Is that right?
Yeah.
And 13.2 divided by 2.4 is.
5.5.
Is that right? We agree?
I believe so.
I agree.
All right.
I'm just.
All right. Number 9 through the rest were all the special case ones. All right. So number 9, n is equal to -18.
Yes.
I got 6.
I got -16.
I got negative 18.
So we would have gotten 144 if we added 8 to both sides. I'm sorry, if we subtracted 8 from both sides. Sorry. So -144, and divide 8 into 144. That would be 18.
Let's go.
Negative, correct. All right, number 10.
12.
X equals 12.
Yeah.
Number 11.
0.
X equals 0.
Mm-hmm.
Number 12.
Negative 3.
-3.
No, I'm just making sure they're calling the right answer. Yes, P is equal to 3. -3, sorry. -3.
That's mistake.
No, I corrected myself. Number 13, Jackson says he does not have the right answer here.
-50.
You dropped a negative, Jackson. And 8 times 7 is not 15.
I didn't say 8 times 7.
Yes, you did.
I did add. Oh, I added.
You added. And it's -8 times +7. It should be -56. So we add if we add 56 to both sides, to that we get -126, and -126 divided by -8 is
15.
no, that can't be right.
15. Wait, what? I made sure because I checked on my calculator after I finished.
Yeah, that's a good.
It's 15.
Is it 126? Is that right?
It's 120. It's
It's
-120.
Okay, so it's a 56, right?
Yeah.
Got it. So yes, you're right, Jade. All right. Number 14. Let's see.
114.
There'll be a +16, so we need to subtract 16 from 104. That would give us a 86. Is that right?
I got -11.
Hold on. That would give us 88 or 86? 88. 8 positive 88, and so that would be in fact -11. All right. So A equals negative 11 over 14. Don't try to do too much algebra in your head like I did. That's very, you can tell that you can make lots of errors that way.
Wait, what was 14?
14? What did I say, negative 11? Yes. All right. Hey, a couple of you guys in this class, Hannah, you're asleep right now. Wake up. Hannah. Hannah. Thank you. Get up, please. You won't fall back to sleep. So a couple of you are getting a little bit lazy towards the end of the quarter. By the way, the quarter's over. We're starting a new quarter. Let's start off on a good foot. Let's just make a devotion that we're going to do our homework, right? Doing your homework, 1, keeps you up with the class. 2, allows you to come to class, ask some questions about something you don't understand. And then 3, you don't lose points, right? Homework is a completion grade. It's not an accuracy grade. Jackson got plenty wrong on that, right? But we're going to fix those mistakes because it's more of a practice day. And he's going to get 10 points for turning in his homework. But the rest of you that don't turn in your homework, you get 0s. That's crazy. Turn in your homework, right? The habits that you set right now, you set for the rest of your academic career, whether that ends at high school or goes to college. If you know your role and know your job to do right now as a student, you'll be fine. Next year, literally, is when you get that tattoo of academics. The tattoo of academics is what happens in high school, right? You literally, that grade never leaves you for the rest of your life. It's like a tattoo. No, I'm not telling you guys to get tattoos, but it's like a tattoo in the sense it's permanent. No one will ever require you to turn in what you got in 8th grade math on any job interview. However, most jobs require you to turn in a transcript of your last grades of your higher education, high school, college, right? They're gonna, Mr. Surratt always tells a story of his wife who's in current job. They asked her why she got a C in high school chemistry, because you got to turn in your transcripts. So the habits that you form right now, you got good ones, great, right? You're gonna get the best grade you can. If you have weak habits, those C's and D's that you get in freshman year, and if they stays that way, that affects what colleges you can get into. And then, like I said, it stays with you forever, whether you want it or not. It's with you. Yeah.
So you're saying if you get an F on a paper, they have that forever?
Well, they don't, not individual papers,
or
but
in the grade itself.
The grade itself.
Oh.
So your GPA, your grade point average, is a permanent part of your life from high school onward. So I don't want to sound, ominous and like, oh, woe is me type thing, but it's also, you only get one shot at most things in life. No, I'm not going to break out into a whatchamacallit rap song. Yeah. No, the one rap singer has got you only got one shot. Eminem, or whatever that guy's name is. But it's the truth, unfortunately. So take your best shot every time that you try something, especially academically. What's up, Genevieve? Say again? I know you don't, because you weren't here yesterday. All right, I got you. All right. So today is a quasi new stuff. It's not really new stuff. I will show you a class, but it's going to combine mostly the special case ones on the back with a brand new thing. Just
It's easy.
Brand new one.
All right, we will see.
Oh, we get another worksheet. Can I have it now?
No, I got to teach you the new stuff first.
But you said I got it right.
Yeah.
The distributive property.
Yeah, I got that right.
Landon, if you grab that stuff off my desk, I'm giving you double homework.
Wait, I want.
All right. All right, calendar. We'll talk about what's on the quiz tomorrow. Worksheet tonight for homework.
Give me.
What do you working on the best?
Are you guys going to actually listen this time?
Yes.
The reason why there's so many worksheets is because we're still on the same lesson that we were on 3 days ago. 5.5. Our book, in my opinion, did a poor job. It introduces way too many things at once. It assumes that you already know how to solve multiple step equations. We literally just did 2 steps, and then it jumps to multiple steps and throws 4 or 5 things at you at once. I choose to break this up into 4 days. One lesson, 4 days. So there's only enough homework for one lesson, so therefore I had to make worksheets. Yes. All right, here we go. We're still on 5-5, but it's the third day of 5-5. All right, lots of steps today. All right, so multiple step equations, you know, we finished with 2 steps. We don't say, hey, here's a 3 steps, here's a 4 step. It's just too hard. We say multiple steps or more than 2 steps. All right, this is a, because that's going to take us multiple steps.
No.
How many steps? One. There's one number to get rid of. That's why that's called a 1 step. Okay, get rid of the 2 and you're done. This is a 2-step equation. Now, I just want to point out, a 2-step equation is 2 1-step equations. We get rid of the -4 and then we get rid of the 2. But each step is a 1-step equation. So, you know, the reason why I made a big deal about when we started off this and at the start of the chapter we did 1-step equations is because all you're doing is doing multiple 1-step equations. All right, that's called a 2-step because there's 2 numbers to get rid of. This is the one that we'll be doing today. All right, it's got multiple things that we need to do. I got a 3, a 2, and a 4 I need to get rid of. There's 3 numbers there I need to get rid of. Okay? Now, as soon as we get into multiple step things, some other things can occur. So that's what we're going to explore today. 2 of the multiple things that can occur. There's lots of things that can occur. We will only look at 2 of them today. So 2 flavors today, but there are certainly more. That's for tomorrow's class. All right, so we're going to look at ones that look like this. Do you see the equal sign? How many things are on the right?
1.
But there's lots of things on one side. Okay? We'll look at that one. This one's going to be combined like terms. And the second one, the one that you've already seen before, because we need practice on this one, involves the distributive property. So you should be able to already do this one. You had it for homework last night. We'll spend the most time on the combined like terms one. But I always throw some distributive property in there just so we have practice. Okay. In box 1, notice the equal sign separates the left side from the right side. On the right side, there's only one thing. Okay? I don't need to move things from one side to the other. What I need to do on ones that look like this is I need to look at each side, one side at a time, and see if there's anything we can group together first. Before I decide to move things around, this will always now be your first step. We need to see if we can combine like terms. Hey, is there anything on the right side that we can group together? Anything. Make sure that winds up with me, Jaden. Right? Is there anything we can group together on the right side? Yes or no?
No.
How about on the left
Yes,
side?
yes,
Is there
yes.
anything we can group together? So if I look at just the left side, you notice we have what is called like terms. Things that are alike. Things that I can group together. Okay? I can group an M and a 2M together. Notice I'm not trying to move these to the other side of the equation, from left side to right side. I'm just saying, hey, they're next to each other. They're on the same side as the equal sign. I can group them together. If it literally said 3 plus 2, instead of writing 3 plus 2, I could write 5. But this time it says M and 2M. How do I group an M and a 2M? Well, I need to know that in front of that M is what number?
1.
There's always a 1 there, right? In general, what I'm going to do is I'm going to group together whatever I can group together, and then it turns into a 2-step equation. You're going to see what happens. And we know what to do once it gets down to a 2-step equation. So let's do one. Okay, same one. So what I'm going to do first is I'm going to look at each side, left side, then right side, whichever pattern you want. And I'm going to see if there's anything on that one side I can group together. For this one on the left side, I can group together the M and the 2M. What's M plus 2M? 3M, right? Why? Because there's really a 1 there. We just choose not to write the 1. 1M or 1 monkey plus 2 monkeys is 3 monkeys. Those are like terms. I can't group the M's with the -4. There's no M on the board. But I certainly can group 1M and 2M. What's up?
Would that be M to the 3rd power then?
We're not multiplying, right? We're not doing multiplication with exponents. We're doing just addition. It's like you got these M's over here, you got these M's over here, you push them together and you count how many M's we have.
Then would it be M to
are we multiplying? There's no multiplication there. There's addition, right? So when we add things that have variables, we do nothing with the exponents. Only when we multiply, or power to power, do we mess with the exponents. Hey, guess how many step equation do I have now? Just a 2-step equation. It started off as a 3-step, but now it's a 2-step. So when we get to a 2-step, the rule is we get rid of addition, subtraction first, unless it's one of those special case ones. This one is not. So what am I going to do to both sides? Add 4 to both sides. 14 and 4 is 18. Last step. Therefore, m equals, remember the 3's not 0, right? M equals 6. Okay? So we talked about a check step when we did 1-step equation. It seemed ridiculous. Now, all of a sudden, maybe a check step sounds like something we might want to do. I mean, I'm claiming that 6 is the answer. So I'm claiming that 6 is the answer to that. Well, let's see if it's true. Everywhere you see an M, write a 6. What's 2 times 6? Plus 6. Minus 4 is absolutely, we got the right answer. So maybe that makes sense now to do a check step if you have time. Check steps are never required, but certainly you can check to see if you got it right. All right, here's another one. Notice on the right side, is there anything you can group together? Eventually there will be, but there's only a 41. What am I grouping? On the left side, is there anything to group together? What can I group together? The S's. 1S plus 3 S's. Just be careful. I'm giving you easy ones to start off with. There's going to be positives and negatives involved. You got to still follow the rules of same or different signs, right? 1S and 2S is 4S. Now it's a 2-step equation. We can solve. You don't have to write 2-step, but Jenna, what's the first thing we're going to do here? I think so. What are we going to get rid of? The 4 or the 5? So what are we going to do to both sides? Both sides. 45 minus 5 is 36. Last step, everybody. But next year, you're not going to even write this down. You're going to write the answer. But this year, you need to write that step down. I'm saying you're going to do every single equation that we solve from now on eventually turns into a 2-step. You're going to be so tired of writing these individual steps by next year, Algebra 1, that you're going to say, you're going to go here, here, answer. You're not going to want to write this because it's obvious. It may not be obvious to everyone in this class right now, but a few of you are kind of like, oh, it kind of seems like I'm doing extra work. I got to tell it the answer from right here is that S is equal to 9. Next year, I'll allow you to skip the steps, not this year. All right, I'm not sure why that's out of order, but imagine that's not there. All right, so let's see. If I look at the original equation, is there anything to group on the right side? On the left side, what can I group together? Well, the 4, it doesn't have an X on it, so I can't do 4 and 2. What can I group together? How about 4 and negative 10? Could I not do 4 minus 10? Okay, so what's 4 minus 10? Okay. There you can see why I'm adding 6 to both sides. So it's a 2-step, add 6 to both sides, therefore X equals 11. Okay. So these will come in 2 flavors. The first flavor is where you're grouping together, we call these constants, 4, negative 10. The second flavor is when you're grouping together variables. In both cases, you group them together, it turns into a 2-step, you solve the 2-step.
Say if it's like 4P and like 6P, would you group?
Yes.
But minus in between, you subtract 4 from 7.
Well, whatever the minus sign is next to is what gets the minus sign. In this case, the minus is next to the 10. Remember, the sign of whatever it is, variable or number, is always to the left. All right. Let's do one. All right, here we go. Box 2. Anything to group on the right side? Just be ready. Eventually there will be. Anything to group on the left side? So I got a 10y and I got a minus 4y. What's 10y minus 4y? Okay, that's not too bad. And now it turns into a two-step. I agree, but I didn't show you this on day one because it wasn't easy on day one. It's easy now because you've done lots of two-steps. What are we doing to both sides? Add 1. That gives me an 18. Therefore, y equals 3. We divide both sides by 6. Stop me if I'm losing somebody, if I'm going too fast. There will be. All right, box number 3. You want to try these by yourself? You want to do them together? All right, do them by yourselves. I just move things around right or left side. Remember, you got to look at both sides. Both sides. Yes. Well, what's 5x minus x? So it wouldn't be 6. Yes.
Is the minus, is that negative 17?
Both. You got to wrap your head around that minus and negative, at least in the algebra world, mean the same thing. Sometimes we say minus, sometimes we see negative. It just depends. If it's literally the first thing that's written in an expression or equation, we say negative. If it's anything other than the first, then we say minus. Where do you see a minus 7? I see a minus 7p.
Okay.
I'm just saying right here, read this. We wouldn't say minus 27 equals, but we could. It's just customary to say when the negative is literally the first thing that's written, we say negative. Okay? When the minus sign happens somewhere in the middle, we don't say 5x plus negative x. We could. We say 5x minus x. Anybody need help? Which one? What's 5x minus x? Think of x as a thing. I have 5 x's and I have minus an x. So 5x minus x. If I said x or xylophones instead of x, you'd get this immediately. 5 xylophones minus 1 xylophone. See what I mean? All I did is instead of saying x, I put a word on it, and all of a sudden, oh, I get it. I'm not sure why that helps, but it helps. By the way, mathematically, that's not correct because really what it says is 5 times the number of xylophones minus 1 times the number of xylophones. That would be mathematically correct. But the idea of the mechanics of it would be you take the coefficients and in this case you subtract. David? Well, what's its sign? Genevieve, you had a question? Okay. First one, 5x minus x, we finally agreed was 4x. Divide both sides by 4, and we get x is equal to -3. Very good. Notice I skipped a step there, combining like terms. All right. This one, once again, the big question was, is 7 positive or negative? When we look to the left, it's negative. Or it's minus, if you want to say that. 4p minus 7p, the signs are not the same. The signs are not the same. We subtract big minus small. 7 minus 4 is 3. There's more negatives than positives, so -3p. The question is, where do you write that? Some people would write -3p first. Some people might write 5 minus 3p. They're both the same thing. Okay, we got to get rid of the 5 by. So we subtract 5 from both sides. Same signs means. So -6. Stop me if I'm going too fast.
Too fast, too fast.
P equals +2. Negative divided by a negative is a positive. Like 2, yeah, because remember we're dividing both sides by -3. So P equals 2. You okay?
Sure.
All right. Nothing to do on the left side here, but on the right side, 8x minus 5x is?
That number.
3x. By both sides by 3, we get x equals -9, or -9 equals x, however you want to write it. We okay?
Yeah, sure.
So technically, that's the only new stuff for today. There is something at the end, some word problems, but it's not really new.
Are you joking
Right.
me? Boo.
All right. Let's just look at the distributive property just to make sure we got our P's and Q's lined up, or in this case, our X's. All right, when you have the distributive property, we take what's on the outside through multiplication and distribute it to everything on the inside. Remember, there's no space between that 2 and then open parentheses. There's no minus sign, no plus sign. That means multiplication. So that 2 needs to go to everything through multiplication on the inside. I highly encourage you to draw the arrows. If you draw the arrows and you look, it will tell you what you're multiplying. What am I multiplying here? I'm multiplying a 2 and a 5. 2 times 5 is, so it's 10x. The second arrow, notice I didn't draw both arrows and then do the math. I drew one arrow and then did the math. I find you make fewer mistakes. The second arrow, Hannah, what am I multiplying? Just look at the second arrow. That's not a 3. 2 times negative 3 is? And we write negative 6, except it looks like I wrote minus 6. Remember, it's the same thing. And we're done with the distributive property. Right equals 14. Now it's a 2-step equation. Add 6 to both sides. Divide by 10. We get x equals 2. Okay. If there's one that will mess you up, it will be this one. Why? Go ahead.
Because you have to keep the R in the negative.
Why is this one messed up?
Because the both multiplication.
No, that's all distributed property. Because we're distributing a negative 2, and especially when there's negatives on the inside as well. Now, this is where the dropping the negative comes about. You just forget that it's negative. So I'm distributing a negative 2 to the inside. Negative 2 times 3r is?
Negative 6.
See what I mean? How easy that is to make that mistake?
6.
Negative 2 times positive 4 is?
Negative 8.
Negative 8. If you're not paying attention, all of a sudden those rules of multiplying with positives and negatives causes problems. We could, but I'm not going to write it that way. Why have an extra sign? Doesn't matter, so don't do it. Would I mark it wrong if you put plus negative 8? No. Just extra signs. Equals negative 20. Everything's negative. Add 8 to both sides, and then people will lose their brains, and they'll forget whether they're adding or subtracting here. Same or different signs? Different. So some people actually still need to think that through. Other people just look at that and say negative 12. Doesn't matter where you're at. I said by Christmas, most of you would be good to go. But some of you still need to go through the process, same or different signs. Add or subtract. Oh, subtract. Big minus small gives me 12 more negatives and positives. That's perfectly fine for 8th graders. Right? By Algebra 1, you shouldn't have to think about it. It should be part of you. Divide both sides. Once again, you'll probably drop a negative. Divide both sides by negative 6. Negative divided by negative is a positive. Cancel.
2 equals R.
Or R equals 2. Jaden.
Could you have divided, like put a big
Yeah,
fraction bar?
you can. I'm going to show you that, but just not today. So the reason why, and this is for Jaden, just to answer his question, the reason is eventually I'm going to have that. That's tomorrow, right? I'm going to have 6r minus 2 times 3r plus 4, and then you can't divide by negative 2. Or I should say, it's not the most efficient way of doing it. So that's the answer to that. But you are right. We could have immediately from the start, I don't want to show this to everybody, but I will. We could have immediately from the start on this one, everything by negative 2. That's dividing everything by negative 2. But eventually we're going to have stuff out front, and then people, if they do that, then they forget to divide everything by negative 2, and they run into problems. So I don't recommend that technique, right, in general, but I certainly show it in Algebra 1. Let's do one. Here we go. Box 4. Yeah, I already causing confusion. I shouldn't even gone down that road.
Math mistake.
All right. How's there a math mistake? I haven't even shown you any work.
I'm
Oh,
guessing.
gotcha.
Do I get an extra point for when I corrected you saying it was 68 instead of 60?
Yeah, you do. I just have it written up there. All right, here we go. Distributive property. This is definitely the one that causes problems when you use the distributive property because there's negative outside, negative inside. First arrow, I only draw one arrow at a time and I do the math. -3 times 2x is. Make sure that you're not letting a few people yell out answers and you are lost. Right? Second arrow, -3 times -5 is. I heard -15 from some of you, right? But it's certainly +15. All right. And that equals 45. Now it's a two-step. Do what?
Divide.
Subtract 15 both sides. That gives me 30. Stop me if I'm going too fast. It's not 6.
-5. -5.
It's divided by -6.
It's 5.
It is
It's -5.
not.
No, it's 5.
It's -5.
It's -5.
You are wrong.
Oh,
The most common mistake in algebra is to you drop a negative. And drop a negative just means you just don't do the multiplication division right with positives and negatives. Right? It's a really easy thing to screw up. So it's worth to go a little bit slow. The nice thing, I mean, this is when it becomes enjoyable to teach algebra, is that now we all know the rules, and we're not spending time on little simple stuff like, hey, what's attached, how it's attached, what do you do, inverse operation. Now we know the things. Now our mistakes are minor. Dropping a negative is a minor mistake. It's not like -4 points off of that. It's still going to be a -1 for dropping the negative.
no.
All right. All right, do box 5 all by yourself, and then we'll do the last stuff, and we're done.
Oh, no. Why? What?
It's easy. Don't.
No,
It's
not,
so
not
easy.
number 5. Number 6 and 7.
Those are so easy.
I know they're easy, but still.
They're word problems.
Why?
It's like
This is so
I know,
hard.
Still.
Man, this is the
There are many things in life
Just because it has words.
I give up.
that are challenging. This is not one of them.
I just don't like
This
words.
is hard.
This is the easiest word problems of word problems.
These are the hardest.
No, the
of hardest.
easiest word problem
It's
is
a word
how do
problem,
you
but
do
it's easy,
one
still.
plus
Jim has
one?
This one is pretty easy.
What is the
Timmy
sum
has
of
Are you
one
already done the
plus
2
one.
problems? Get them done.
Easiest
Jaden, are you already done these 2 problems? Now stop disturbing the people around you.
Yeah,
You're talking to each other. You're not even caring.
Jaden, turn around.
Two.
And you still owe me the note that you've been passing around.
I'm passing around.
Jaden.
What?
All right, everybody else stop, get your work done.
Yeah, I know.
All right, first one, distributive property. Let's see. The first arrow give me 8q. The second will give me -28. Add 28 to -4, and you get 24, right? And 24 divided by 8 is
3.
q equals 3. All right. Second one, we're distributing a -5 to the inside, so we get -10x minus 15 equals 5. Add 15 to both sides, that would give us 20. Divide both sides by -10, x equals -2.
How'd you get through?
All right. The other nice thing about once we get to this level is that I usually don't have to point out mistakes any longer. You like, wait, he got something different than I, and then you look at your work, and it becomes easily apparent to you guys where your mistakes are at. I'm just going to warn you. By the way, how many steps did we do for this one? 1, 2, 3, 4. That's a 4-step equation. All right. We will eventually get to maybe 6 steps this year, right? But not much more than that. There certainly are 20-step equations, but you know that's beyond the scope of what we'll be doing this year.
What's the 20 step? Why?
There's lots of complicated things, right?
20 steps.
Lots of complicated things. So if it takes 20 steps, it takes 20 steps. But I mean, I can't tell you that everything in life is a 2-step equation. I wish. If it only took 2 steps, life would be easy. All right, any questions on this stuff?
Yes. No.
All right. All right, new stuff. Think about this. All right, you saw this last year. You were exposed to this. You may not remember this. Do you remember consecutive numbers?
No. I have no
Can you
idea.
give me an example, somebody, of consecutive numbers? JD?
You get like one and then.
Just give me an example.
They're the same number.
Can anybody else give me an example of consecutive number? He was wrong, by the way.
3 and 6.
Go.
1, 2, 3.
Why is 1, 2, 3? She's right. Why is 1, 2, 3 consecutive numbers?
They go one after
Right. So the basic definition we're going to say are numbers that are increased by,
1.
and numbers that have been increased are consecutive numbers. So if I start with 10, the next consecutive number would be
11.
okay, 12. There's nothing special about 3 of them, but yeah, we'll be doing 3 consecutive numbers. Any questions on what a consecutive number is? All right, Hannah, start with 99. What are the next 2 consecutive numbers? All right, and if we stopped right there, you guys would be happy because it really would be that easy. We're going to do this algebraically. So all I'm going to do is take my eraser, and I'm going to, oh, that didn't work. I'm going to erase those numbers, and now they're going to be, we don't know what they are. We have to figure out, and that's for the people that are reading ahead. That's what the goal here is. I'm going to be thinking of 3 consecutive numbers. I'm not going to tell you what they are. You got to figure them out. You're like, well, that sounds impossible, right? So, unknown consecutive numbers. I'm not going to tell you what they are. You're going to figure them out somehow. So, if they're unknown, then the first one is obviously a variable, right? Because we don't know what it is. Okay, so if the first one is x and they are consecutive, imagine this. What's the relationship between 10 and 11?
1.
So if the first one is x, the second one is going to be, could be another variable, but you just told me that to go from one to the next, you just basically, so let's just add 1. So what's the next number? Well, that can't work. Well, if this number is 10, the next number would be,
11.
so what am I going to write right here? If the first one now is x.
X, 1x.
Okay, 1 times x, we still are 10. How do we get from 10 to 11?
1.
What'd you say?
1 plus x.
Would that get us to 11? All right, well, if the first one is x, the next one is going to be, we'll take the first one and do what to it? Add 1 to it. So therefore, it's x plus 1. He said 1 plus x, the same thing. See how that works? So if the first one is 100, we take 100 and we, well, that's your next consecutive number. What's the next one?
X plus 2.
X plus 2. Sounds good. It's not that bad, right? So these are going to be our 3 consecutive numbers. Now we could say x, y, z. That would work as well. But this is easier because now there's only one variable, just x. We don't have 3 variables running around. So the first one is x, the second one is x plus 1, and the third one is x plus 2. What's the fourth one?
X plus 3.
All right, you got it. All right. So here's the word, and it's the easiest word problem. Oh, it says the sum means what?
Addition.
Of 3 consecutive numbers is 15.
Yes, sir.
Well, I already know what the first one is. The first one is always,
1x.
the first one is always, the second one is
1x.
1x.
x plus 1. And then the third one is,
X
X
plus
plus
2.
2.
so that's easy. I mean, if you have to write 10, 11, 12, just so that you can keep this fresh in your mind, do that. But the first one is always x, plus, because it says sum, the second one is always,
X plus 1.
and the third one is always, and it says the sum is what?
15.
Okay, then we just solve this equation.
1.
Hey, what can we group together?
X.
How many x's do we have?
15.
So we got 3x. Hey, what's 1 plus 2?
3.
So if we group together the x's, we have 3 of them. And if we group together the 1 plus 2, we get, and now it's a 2-step equation. Hold on a second. Now it's a 2-step equation. Could you solve this?
Yes.
X represented what? The first, the second, or the third number?
The third.
X represented the first, the second, or the third number? The first. So you are solving for the first number. So let's solve this. What do we do? Both sides. Now what? So x equals?
4.
So what's the first number?
Number 15.
So what are the three consecutive numbers?
4, 3, 4, 5, 6.
That's pretty simple, right?
Oh, gee.
So if x is the first number and they're consecutive, it would be 4, 5, 6. 4 plus 5 is 9. 9 plus 6 is 15. Now, I gave you a nice, easy number that you could guess and check. Pretty easy. But tonight for homework, they won't be that easy. Okay. All right, let's do another one. The sum of three consecutive numbers is 66. What's the first number? It's always, the second one is always, and the third one is always, and it equals 66. X plus x plus x.
3x.
1 plus 2 is, three consecutive numbers will always be 3x plus 3. Four consecutive numbers is not 4x plus 4, though. It'll be 4x plus 3 plus 3 is 6.
You really don't have to do the top. You can just see how many numbers are.
Yeah, but what happens if that's a funky number? Okay. All right. Now we simply solve this. And remember, when we solve for x, we're solving for which one of the numbers? X represents what? The first, the second, or the third? You're always solving for the first number. Then it's easy to make the other two. Subtract 3 from both sides. Divide by 3. So my first number is 21. Therefore, the three consecutive numbers are?
21, 22, 23.
That's not that hard.
I have a question.
What?
So how do you know when to stop going up? Like x plus.
Well, it said only three consecutive numbers. If it said four consecutive numbers, then there would be also an x plus 3. All right. The sum of three consecutive numbers is 30. What are those numbers?
15.
You want to say
Oh,
10, 11, and
9.
12, don't you? That's wrong.
9.
All right. So let's see. The first number is always, the second number is always, and the third number is always x plus 2. Okay. Equals 30. How many x's do I have?
3.
In fact, you do this so many times, you just basically skip this step and write for x plus 3. Because you know that's what three consecutive numbers are, 3x plus 3. 4 is not 4x plus 4. Because if we had one more, it would be x plus 3. Well, that would turn into a 4x, but 3 plus 3 is 6. So you'd actually get 4x plus 6 for four consecutive numbers. The book always chooses 3, and this causes some problems. 2 would not be 2x plus 2. 2 would be 2x plus 1. Two consecutive numbers is 2x plus 1. All right. Now it's just a simple algebra problem. Therefore, it's 9. All right. Now they can cause you problems by doing this one slightly different way. This says the sum of three consecutive. They can also ask the question, three consecutive even or odd numbers. Now it becomes a much more challenging, it seems like, problem. It's solved the same way. Give me three consecutive even numbers.
5, 6, 7.
Even numbers.
4, 6.
Okay. So if I start at 10, the next consecutive even number is
12, 14.
So what's the first number? If we don't know what it is. Now what's the second number? What's the third number? See how that changes? Now I'm going to blow your mind. Okay. How about three consecutive odd numbers?
No. 5, 6,
1,
5,
5,
7. 1.
Give me three consecutive odd numbers.
5, 7,
9, 11, 13, 15.
How do you go from 11 to 13?
Plus 2.
How do you go from 11 to 15?
Plus 4.
It's the same as even. It doesn't seem like it would be, but it's because you're starting with an odd number. Odd numbers are always increased not by 1. That would make it even. Odd numbers are always increased by 2. So listen please, three consecutive even or odd numbers is this pattern right here. So 3x plus 6 equals whatever the sum is. Okay? All right. That'll finish it for today. Here is your worksheets.
Oh, I got one. This for the whole row?
No, that's for me.
Pass behind you. Pass behind you. Pass behind you. As soon as you got one, you may leave.
Thank you. Bye. Have a good day.
Nope. I'll watch it for him.
Genevieve, I need to hit you up for
Oh, by the way, I'm taking back my old seat today.
Your old
All right, e-learners, if you have any questions, let me know.